Okay, so as I said just now, for the circuit theorem, we will have these five topics lah, where we have superposition, source transformation, Thevenin's theorem, Norton theorems, and maximum power transfer. But for these topics, we will cover in this lecture. We will cover these two topics lah, superposition and source transformation lah. Okay. So for a superposition, okay, what is the superposition theorem? Okay, superposition is a method to determine branch current or voltage in a linear circuit that has multiple sources by taking one independent source. So you just only have to take one independent source at a time alone and algebraically summing the results. So means that for this superposition, we will determine the branch current or voltage, all right? Okay, so let's say you have, we only take the independent source, and the dependent source we just left intact lah. So this superposition theorem is a method to determine a branch current or voltage. It depends on the question lah, okay, which has a multiple sources. So means that in your circuit it might have one or more than one sources lah, which is for voltage or current sources, and it's only involved with the independent source only. Okay. So a linear circuit is actually one whose output is directly proportional to its input. So a linear circuit is actually involved with voltage, current, and resistor. So this component, instead of resistor, you also can have the inductor and also the capacitor lah. So this is, we call it as a linear circuit lah, because like the one that have the voltage, current, and resistor, because we can have the current which is proportional to voltage, where we have this Ohm's law lah. Okay. So for this superposition theorem, you can just ignore the dependent sources that we have in the circuit lah. Okay, so means that this superposition theorem is a fundamental principle in electrical engineering and also in a circuit analysis, that in circuit analysis where we can simplify the analysis of complex linear circuit lah. Okay, so means that we can, with this superposition theorem, we can analyze a linear circuit which does not directly apply to power calculation due to the nonlinear nature of power lah. So you can see that this limitation here, right? So we cannot calculate power using this theorem lah, superposition theorem. Okay, because power analysis in circuit require considering all sources and components simultaneously and applying the appropriate mathematic relationship lah. Okay, because you know that for power we have the multiplication of this current and this voltage, right? So this we call it as a non-linear function lah. So for a non-linear function, we cannot use it for the superposition theorem lah. Okay. And then the step to use for a superposition theorem is that the first thing that we can do is we need to deactivate or replace the other source with their internal resistance of voltage source or current source lah. So if you have a voltage source in your circuit, right? So this is actually the voltage source. So what you have to do, you just need to make it a zero resistance or the short circuit lah. So means that the short circuit, from this you can just short the circuit lah. This, just put a wire, so then it will be short circuit lah. Okay, and then for a current source, we can replace it with the open circuit. Okay, let's say you have the current source, right? So you can just leave it open. okay, and then the other component is connected like usual lah, but you can just leave it this open lah, open circuit. Okay, so it's better for you to redraw the circuit for better visualization lah. So means that if you have this question, it's better for you to redraw the circuit each time you want to deactivate the sources lah, right? For the voltage or for the current, it's better for you to just redraw the circuit. Okay. And after that, after you select one of the source, then you can calculate the output, which is depends on the question whether it asks you to calculate for the voltage or current lah. For the active source alone by using the technique learned in chapter 1 in chapter 3 lah. So means that for these circuit theorems, means like for the superposition, source transformation, Norton Thevenin, you will use all the techniques or analysis that you have learned in chapter 1 and chapter 3, which is involved with the current divider, voltage divider, series parallel, resistor, Ohm's law, KCL, KVL, mesh analysis, node analysis. So you will use that knowledge in order to solve for these circuit theorems parts lah. Alright. And then finally, you can total up all the voltage or current that you have calculated. Depends on how many source that you have in the circuits by adding algebraically source polarities lah, by adding all the voltage or currents. Okay, depends on how many source that you have lah. Alright, okay, it's better for me to show you the example for this one, right? Okay, like for this one, the question asks you to use the superposition theorem to find the V. Okay, this is the V that you need to find in this circuit. So the first thing that you need to find is that to look how many sources that you have in this circuit. All right, so obviously from this circuit you have two sources, right? You have one source, you have two sources, which is coming from 6 volts, and the second one is coming from this 3 ampere. So means that you need to add the voltage from this to get this value of V. So means let's say from the first source you just put it as a V1, and then the current source just put it as a V2. So you need, in order to find this value of V, you just need to add up this V1 plus V2, V1 plus V2, and then you can get the value for V. So that is the superposition. Okay, so just look at, and then in order to calculate for this V, you just need to turn off one of the source first. You just calculate one source at a time. All right, for example, you want to calculate from this source first, from this 6 volt voltage source. So you just need to turn off this one. In order to turn off the current, you just need to leave it open circuit lah. But for the voltage, you can just do the short circuit. All right. So if you redraw the circuit again, you just have to eliminate this one. Okay, turn off this. So you will have your circuit like this lah, because this current source will leave you with the open circuit. Okay, so it will happen like this lah. Okay, and then you need to calculate V as a V1. All right. Okay, let's say here just V1 and this one is V2. Okay, no, betul lah, V1, this one is V2 lah. So from this 6 volt, we calculate V1 lah. We calculate to get the V1. All right, so how to calculate V1 here? You can use all the techniques that you have learned in previous topics lah. Okay, so like for this one, what we'll do is that, okay, so to obtain V1, we set the current source to 0, which is we set it to open circuit lah. Okay, and apply KVL to the loop as in 1A. So you can just apply the KVL in order to find the value for V1. Okay, what you can do is that, okay, just put the I1 here. So just remember the KVL, right? KVL is the sum of voltage is equal to the sum of voltage is equal to 0 lah. Okay, So you can start from here lah. Let's say you start from -6 here. -6 plus with 12 here, 12i1, 12i1 equal to 0. So you can get this i1. Okay, once you get this i1, so means that you will have 12i1 equal to 6. So i1 equal to 6, 6 over 12. So you will have the I is 0.5a. And then in order to find v1 here, so v1 is actually equal to i1 times with 4 lah. Okay, this is Ohm's law. So then you can just times 4 times with 0.5. So you find that your v1 is equal to 2 volts. So means that you already have the value for this v1 is 2 volt lah. All right, and then you need to find the value for 2a when you deactivate this voltage source. All right, so means that this part lah, when you activate this voltage source, so you will, when you redraw again your circuit, it will look like this lah. Okay. Okay, so when you deactivate or eliminate this voltage source, you will have a short circuit here. Okay, it means that you just put a straight wire lah. Okay, and then from this one, you can calculate it using the current divider. I think that you remember the current divider, right? You can just use current divider theorem lah, current divider analysis, where in order to find this V2, you know that this V2 is actually equal to I3 times with 4, right? I3 times with 4. So then you can find the value for V2. So how you can get the value for I3 here? So then you can use the current divider. So I3 here is actually equal to, okay, I3 here is actually equal to I2 over the total resistor, okay, which is 12 times with this 12 times with this current source times with 3. So now you can get your I3, which is equal to 2 ampere lah. And then you can substitute this value inside here, where you know that V2 is actually equal to I3 times with 4. So then you know that I3 is equal to 2 times with 4. So your V2 is equal to 8 volts. So 8 volts here. So means that you already found that your voltage from this 3 ampere is actually equal to 10 volt. So in order to get the value for V, you can just add up these two. 2 plus with 10, so it will equal to 12 voltage. So means that the value for your V here is actually equal to 12 voltage lah. Okay, let's say if you have three sources, means like let's say you have 3 voltage source, so means that is the question asks you to calculate the V, so means that your voltage needs to come from V1 plus V2 plus V3. This one if you have the 3 sources lah, okay. So this superposition is depends on how many source that you have in your circuit. It's only the independent source. So that's not the answer. Okay, let's move on with another example lah. Okay, so for this example, the question asks you to evaluate V naught here. Okay, so V naught here. You know that using the superposition theorem, look at how many source that you have here. So means that you have 2 source, right? One from the 5 ampere and the second one is from the 12 volts. So means that your V naught is actually coming from V1 plus V2 lah. Let's say 5 ampere is V1 and 12 volts is V2. So you need to calculate these two value. Means that when you turn off this 12 volts, you can have V1. When you turn off this 5 ampere, you can calculate for V2 lah. And then you can just add up these two value to get the value for your V naught. All right. Okay, let's see how you can do that. All right. So this already explained to you. let's make it V1 is actually from the 12 volts, and then V2 coming from this 5 ampere source lah. All right, for this solution, so means that for V1 is coming from 12 volts and V2 coming from the 5 ampere. Okay, and then you can just add up V naught equal to V1 plus V2 in order to get the value for V naught lah. All right. Okay, so what you can do first, when you turn off this current, so your circuit gonna be like this. In between this, it's gonna be an open circuit lah when you turn off this. So it will leave your circuit like this lah if you redraw your circuit again. Okay, so it will you will have this circuit. So now how can you calculate this value? Okay, this V naught. So we put it as a V1 lah because we just turn off this 5 ohm for 12 volts source. All right. Okay, so to get V1, you can just use the I think this is the KCL, all right? KVL, okay, just use the KVL where you can just put here this loop as I, okay, and then just add all the resistor in for this circuit, just 5 plus with 3 plus with 2, so you will have 10, okay, so we'll have 10 I. If you could, if your current is like this, all right, 10 I minus with 12 equal to 0 lah. Okay, so 10 I equal to 12, so I equal to 12 over 10, so you will have your I is actually equal to 1.2A. And how about your V1 here? So V1 is obviously using the Ohm's law, I times with this 2 ohms. So now you can just I is equal to 1.2 times with 2, so you will get your V1 is actually equal to 2.4 volts. All right, so you will have your V1 is equal with 2.4 volts lah. All right, and then after that we want to turn off this. All right, when you turn off this, it will be short circuit here. Okay, short circuit, just put a wire, and then you will calculate the V2 is coming from this 5 ampere current source lah for this V2. All right, so for this V2 you can use the node voltage or whatever you like lah, but for this one, just you can just consider, okay, if you draw this circuit again, okay, consider this circuit in B. Okay, you look, if you sum this resistor on this one, we call it as the left side, and this one at the right side here, you can see that the total resistor is the same, right? 3 plus with 2, this one is also have the 5 ohm, and this right side also have the 5 ohm, and then we have the 5 ampere source here. So means that the resistor, the current that this right side and left side have will be equal or the same lah. Just 5 divide by 2, so you will have 2.5 ampere for both. So means that in order to calculate a V2 here, so V2 is actually equal to, so means that I1 is equal to I2, which is equal to 2.5A, because it will be divided equally between both sides lah. So V2 equal to I2 times with 2. So you will have 2.5 times with 2, so you will get 5. Okay, so you will have V2 is 5 and V1 is 2.4. So in order to find your V naught, just add up 2 V1 and V2. So then you will have 2.4 plus with 5, then your V naught is going to be 2. So we have another example, okay, for the superposition theorem. So this question asks you to evaluate V naught. The same step that you have to take, just look at how many sources that you have. Okay, if you look at here, you have 2 sources, which is coming from this 9 and 3 volt source lah. So means that you need to have like 9 volt, let's say this one V1, and 2 which is coming from 3 V2, and then for your V naught, obviously V naught is V1 plus with V2. All right, so you need to calculate V naught here, which is coming from 9 volt source and also 3 volt source lah. So first we have to eliminate like from the 9 volts, right? So okay, so we will want to calculate the V1, which is coming from 9 volts. So we turn off this 3 volts here lah. We have to turn off the 3 volt here. So we just leave it here as a short circuit. And then we will have this circuit. If you redraw again, you have this circuit lah. Okay. So it means that you have first 9 volts, which is you want to calculate for V1 here. So you can use node analysis here. If you look at here, it uses the node analysis where you can put here as a node V1 here in order to calculate V1 here. Okay. So just look at the current direction. The first thing you need to remember for node analysis, just draw your current directions lah. For this circuit, I draw the current direction this way lah. Okay, so you need to remember node analysis, you will have the summation of positive current equal to the summation of the negative current. Okay, positive current is actually current entering the node, and the negative current is current leaving the node. Okay, if you look at this node V1 here, so you can see that you have 2 current leaving the node and 1 current entering the node here. So means that you have the 1 current for this positive current and 2 current for negative current lah. Okay, so for this positive current, you will have V1 minus okay, just let's see this one lah, this way. So means that just started from here lah, 0 minus with minus 9. Okay, for this one means that 0 minus with minus 9 over minus with V1 over 3. So for this one, you will have 9 minus V1 over 3. Okay, for this node. Okay, so you can just put it for the positive current here is 9 minus with V1 over 3. And then for your negative current, V1 minus V1 over 9 plus with this one V1 over 1. Okay, so you will have this equation lah. Okay, and then just as always simplify this equation, and then you can calculate for V1. And then when you do your calculation, you will get V1 is actually equal to 2.0769 voltage lah. Okay, and the same thing with V2 here. So in order to calculate V2, we want to turn off this 9 volts here. All right, when you turn off this 9 volt here, you will leave it as a short circuit here, and then you will leave this 3 volt here lah, this side. Okay, it's the same thing that we will use the node analysis lah as well to calculate this V2. All right, so just follow the current directions here. You can see that we will have 2 negative current and 1 positive current lah. Okay, so let's say we will have a positive current equal to the negative current. Okay, so the positive current that we have is 0 minus with minus 3 here. Okay, 0 minus with minus 3 minus with V2 over 1 equal to the negative current is V2 over 9 plus with V2 over 3. Okay, So for this one, you will have 3 minus V1 over 1. Okay, if you simplify. And then equal to V2 over 9 plus with V2 over 3. So you need to simplify this equation. So then you will get V2 is also 2.0769 lah. Okay. And then you know that your V naught is actually equal to V1 plus V2, which is equal to this value lah. V1 plus with V2, then you can get V naught is equal to 4.1538 volts. Right? Okay, so we also have another example where we have the superposition to find this Vx, but you can see that the difference with this circuit is that we have this dependent source, right? But for my previous slide, I said that you just have to look at this independent source, but not this dependent source. So means that from here, in order to find your Vx here, is only involved with 25 volts and 5 ohms. So in order to find your Vx, you need to calculate coming from V1, which is coming from 25, and V2 is coming from this 5 ampere for the V2. So means that your Vx is actually equal to V1 plus with V2 lah. Okay, because for the dependent, you just can left your dependent source intact. Okay, nothing happened or there's not involved anything with the dependent source lah. All right. Okay, so you have this circuit. Okay, so let's Vx is actually equal to V1 plus V2, where V1 is coming from this 25 and this V2 coming from this 5 ampere source. All right, so let's say we want to calculate the value V1 from 25 volt source lah. So we need to turn off this. So means that you will have we will have nothing here lah. You just have left here this like open circuit, and then your Vx will go here lah. All right. So means that this one is going to be your V1 lah. All right. So in order to calculate that, you can use again the node analysis lah. Okay. You can use the node analysis again to calculate what's the value for your V1. First, just draw your current directions, and then you notice that the current directions here are all leaving the nodes, means that all have the negative currents. So means that you will have the negative current, and then for the positive current, you will have zero lah, just equate with zero. So you will just have to put all the negative current for the node analysis lah. Okay, let's say here you will have, this one will have 25. Just follow the current directions here. Okay, for this one means that V1 minus with 25. For this part, it will be V1 minus with 25 over 20. And for this one, it will be V1 over 4. And for this current here, because it has the opposite directions like for this one, so it will be negative lah, negative 0.1 V1. Okay, so let's see here, V1. Previously, your dependent source is Vx, which is depend on this Vx. So let's say when you put it here as a V1, so just convert your Vx here is equal to V1 lah, because your Vx here is actually your dependent source here, it actually depend on this Vx. So means that when you change your Vx into the V1 or V2, just also change these dependent sources to V1 or V2 lah, depends on what source that you turn off lah. Okay. Okay, so you have this circuit, then just put it into this equation. All right, you will have this equation, then simplified. I guess you just need to times this with 20, and then simplify so that you have this, and then you know that your V1 is actually equal to 6.25 lah. Okay. Okay, we've done calculating the V1 from this 25 voltage source, and now we want to calculate the V2 from 5 ampere source lah. Okay, so now we will cut off this 25 volts. So just draw a straight line here. Okay, so you will have, you turn off this part, and this is your V2 lah. So your Vx now going to be your V2, and seems like this one lah, it's also going to be V2. Okay, so like for this one also we using the node analysis method lah to calculate V2. Alright, so you can just draw the current directions. Seems like this previous one. Okay, so this is your node, and you have 1, 2, 3 current, which is leaving the node, and the other one is entering the node lah. Okay, so means that what you have here is you will have this one going to be negative, 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 and then this is one going to be positive lah. Okay, so just put it as a positive current equal to the negative current lah. So for the positive current you will have this lah, 0.1 V2 equal to, for the negative current you will have 5 plus with oh, but you can see here, right? The current directions leaving and this directions is opposite, so you just need to put the negative here lah, -5, right? Because it's opposite directions with your current direction that you draw here lah. Okay, so you can just put -5 plus with V2 over 20 here, V2 over 20 plus with V2 over 4. Okay, V2 over 4, and then you can just bring this 0.1 into the other side and then just equate with 0, so that this one going to be negative 0.1 V2 lah. Okay, and as always, just simplify this, time this with 20, and then you can get your V2 is equal to 25, and then you know that your Vx is actually summation from the V1 plus V2, just sum this value 6.25 and 25, and then you know that your Vx is actually equal to 21. I want to go with the source transformation lah. Okay, so for the source transformation, like the name lah, source transformations mean like from the voltage source you want to turn it into the current source, or from the current you want to turn transform it into the voltage lah. So means like for the voltage, usually we have parallel resistor, right? So when you want to convert it into the current source, all right, so it will gonna be parallel. This one series with voltage, and when you transform the source from the voltage to current source, it will transform the circuit into a parallel with this current source lah. And then the thing that you need to use is just use the Ohm's law, where you have V equal to IR lah. So just rearrange this equation lah. Okay, when you want to find the voltage, if you want to convert from the voltage to current, so you know that in order to calculate the current, so current is equal to V over R. So it's vice versa lah. If you have from this current, you want to convert from the voltage, so you know that your voltage is equal to V equal to IR. Just use this value lah. Okay, right, so that's about the source transformation. So it means that your circuit, you just want to simplify your circuit by transform the source. Okay, based on what the question asks you for your circuit lah. Okay. All right, so this is another tool for simplifying a circuit. Basic tool, which is the concept of equivalence lah, means that equivalence for V equal to IR or I equal to V over R. It depends on what source that you want to transform, whether you want to transform the voltage or the current source lah. Okay, so it's actually a process of replacing a voltage source in series with a resistor. Okay, voltage source is always in series with a resistor. this one, right, series, and a current source which is parallel. Current source always parallel with the resistor lah. And also you need to also notice this polarity for this current when you convert or replace from voltage to current or current to voltage. You need to also note the polarity for this one. Okay, just look at these directions of current, right? If you have these directions of current, so that's mean that your current coming from here going to be negative and here going to be positive for your voltage lah. So this is current, so this is voltage, and let's say your current is coming from this way, your current source. So means that when you transform, it's gonna be your voltage gonna be, this is negative. Just follow the directions lah. Okay, so this coming from these directions means this going to be negative and this going to be positive. Okay, so you have also note this polarity when you converting from the current to voltage or from the voltage to currents lah. Okay, just note this, right? All right, so this is the procedure lah using just the Ohm's law. Okay, as I said before, you need to give attention to the source polarities lah, like this one. If you have positive, negative here, means that your current is this way lah. If you have the negative, positive here, you have this way of current lah. So you also need to note these polarities lah, or else you're going to get the wrong answer lah for your question, alright? Okay, faham tak? So this is the important note that you need to know lah before you transform your circuit. Okay. All right. So let's see this example lah. Okay. So I think that we have time scope to see this example because before it's 11. All right. So use source transformation to find the value for V naught here. You need to calculate the V naught here in the circuit below. Because the question asks you to use the source transformation, so make sure that you need to use the source transformation lah. Okay, so source transformation means that you need to transform your voltage or current, your voltage to current source or your current source to voltage. So that's about the source transformation lah. Okay, so means that whether you need to transform this source, current source into the voltage, or you can transform this part here into the current source. Okay, where for the this one you want to transform into the current source, so you know that you need to note also your polarity here. If this one you want to transform into the current source here, so you know that your current direction must go this way lah. And then for this one, you have this current direction this way. If you want to transform it into the voltage source, so you know that your voltage source gonna be this way lah. Okay, negative first and then positive lah. Okay. So that's the first thing that you need to note before you transform your circuit for any source here lah. Okay. And then what you have to do is that, okay, so let's say first you want to transform this part. Okay. Transform the current and voltage sources. So means that both current here and then the voltage source as well here. You know that in order to transform both current source or voltage source, you just need to use the Ohm's law, where you know that V equal to IR for the voltage, and for I equal to V over R. So means that for this one, you want to transfer it into a voltage source, just use this equation lah, where I times with 4. So means that you will have your voltage here will be equal to 12 lah, V equal to IR. So I is 3 and R is 4. So you will have your voltage source here gonna be 12 volts, and then it's gonna be series with this resistor. Okay, look at here. This one is parallel, but when you turn this current source to voltage source, then you know that you're going to have it parallel series with this resistor lah. And then just look at the polarities, all right? Because your directions of current this way, so means that negative, positive here lah. So this is your current source, voltage source lah. All right, and then after that you want to also turn this into the current source. So current is equal to V over R. So you have V if 12 over 3. So this gonna be equal to 4 volts lah. All right, so that's what 4 ampere. So you have this as your 4 ampere, and then just follow the polarities lah. So it will go this way lah, your directions of current here, and then it's gonna be parallel with this resistor lah. Okay. And then after that, you have this circuit. You can see that clearly that actually you can combine this resistor, right? You can combine the 4 and 2 ohms here. So that's going to be 6 in series, and transforming this 12 volts into the current source, right? From this part here, you can transform. So you actually, if you just draw, you will have 6 and 12 volts of current source from here lah, and then you have another circuit. Okay, but now you want to transform this as well with the current source. All right, so for current source, you know that your current is equal to V over R. So you know you have your V is actually 12, and then your resistor is 2. So then you know that you will have 6. So you have 2 ampere lah. So that's why you will have here 2 ampere, and then it's going to be parallel with this 6. Okay, 6 resistor lah. 6 ohm resistor. So you redraw again the circuit so that you will have this lah. So this part is actually transformed from this part lah, and then you will have this rest of the circuit. So now I think that from here you have both current source here, right? Okay, so now what you can do is that you can just combine you can combine the 3 and 6 resistor in parallel lah. Okay, you can combine this one, 3 from here, 3 and 6 here. Okay, 3 and 6 resistor combined in parallel, because you want to calculate this value for V0, right? So that's why you can just combine it in parallel. Just leave it here because you want to calculate the value for this V0. Combine here parallel while you have 6 parallel with 3. So you will have it equal to 2 ohm, all right? When you combine these two, now when you draw the circuit again, you can have this one, and also you can just subtract 4 minus with 2 so that you can get for the current equal to 2 ampere lah. Because why is it 4 minus with 2? Because you can see the current directions here, right? Here and here. Okay, so 4 minus with 2 dah. If you have the current direction is the same, you can just add the value, but because the current directions is different, so means that it will subtract the value lah. Okay, so means that 4 minus with 2, which is equal to 2 here. This one coming from 4 minus with 2, so you get 2 ampere, and this 2 is actually 6 ohm parallel with 3, so then you can get 2 ampere at 2 ohms. So now you will have this circuit. So obviously you have current source, so means that you can use the current divider. Okay, for this one you can use the current divider in order to get this I, and then you know that V0 here you can get by I times 8 times with I, so then you can get the V0 value here lah. Okay, so means that for this one, in order to calculate this value for I, you can just use the current division. Okay, so I is actually equal to this value 2 over 2 plus with 8, and then times with this 2. So now you can get your current here is actually for I is 0.4. So now you can calculate for V0, 8 times with I. So you can get your V0 is actually equal to 2.0 3.2 volts lah. All right. Alternatively, actually you can calculate since the 8 and 2 ohm resistor in figure are parallel, they have the same voltage. All right, they have the same voltage across them. So also you can use this technique lah, okay, because you know that in parallel you have all the voltage is the same, right? So you can use this just parallel this one will this value means that 8 parallel with 2 you will get how much value, then times with this 2 ampere means that V naught is actually equal to I times with R. Okay, this is the value for your resistor here and then times with your I here. So then you can get the same answer lah, where you can get 3.2 volts lah. All right.